till now we have made a network which has 100 people of different body weights, and then we have 5 social foci including a gym and an eat out place, and we have seen that initially everybody is a part of exactly one social foci, and with time people will start becoming the parts of more social foci because of membership closer. Next, what we want to implement in this coding, what we want to happen in this network is homophily. That is, the people who are having similar BMI should become friends with each other. So we are going to use a very simple method to do it. So we see that the probability of two people becoming friends with each other is inversely proportional to the difference between their BMIs. So more is the difference between your BMIs, less probable two people are to become friends with each other. So if let's say a person is underweight having a BMI of 15 and a person is overweight having a BMI of 40, so it's very unlikely that they will become friends. And if two people they have almost the same BMIs, let's say 25 each, then they are likely to become friends. So we can directly use a formula that probability of two people becoming friends with each other is inversely proportional to the difference between their BMIs. So probability of an edge between U and V is proportional to 1 divided by the absolute difference between them. So we take absolute to avoid a negative there. So we have an absolute there, and we add an extra factor of plus 1000 here. Why do we add an extra factor of plus 1000 here is, if you see by this formula, if we do not have 1000 here and let's say the BMIs of two people are equal, let's say 25 each, then the probability of them becoming friends becomes 1 by 0, which is infinity. So we have 1000 here, which not only help us deal with this infinity issue, what it does is it reduces all the probabilities. So although the probability of one person becoming connected to another remains inversely proportional to the difference between their BMIs, but we want these probabilities to be less, because since we want to see the network to be evolving, we do not want a lot of edges to enter at the same time. So edges should come slowly and slowly. So this plus 1000 helps us reduce all the probability values. It scales all the probability values down. So we use this formula for implementing homophily. And one interesting concept here which I would like to tell you, you see here what we are going to do is, here are two people, let's say A and B, and we are saying that assume the probability with which A and B become friends is 0.4. So there is a 40% chance that A and B become friends and 60% chance that they do not become friends. How do we implement this in our coding? So this random package helps us do this. So what I do is assume I pick a random number, random real number from a number line from 0 to 1 as shown here. I want some event to happen with a probability of 0.4. So now I have a random number here between 0 and 1. So I pick a random number, let's say it's here. What is the probability that this random number is less than 0.4? So since this random number can be anywhere on this number line, if you see, the probability that this random number is less than 0.4 is actually 0.4 itself. So 0 to 0.4 is a smaller slot, 0.4 to 1 is a bigger slot. So there is a lesser probability of this number falling below 0.4 and there is a higher probability it lies in the range 0.4 to 1. So we will be using this method to implement what we are saying. So assume there are two nodes U and V and we want them to become friends with probability 40%, 0.4. What we will do is generate this random number R from 0 to 1, and if its value is less than 0.4, we make an edge between these two people, otherwise we do not make an edge. So now before implementing homophily, I want to do one extra thing. So one, we have added color to our nodes. So we have added blue color for the person node and red color for the foci nodes. What I want to see is, I want to see underweight and overweight people separately. I want the underweight people to appear in, let's say, green color and overweight people to appear in yellow color. So that when we look at this graph across different timestamps, we can see that how the number of people are changing and how the clustering between them is happening. So what we do here is, if G dot node each type equals to person, and then further we have if G dot node each name equals to 15. So what we do is, in this case, C dot append, and what do we append here is a green. And then we have else if, which is written as alif in Python. So alif G dot node each name equals to 40. So if it is 40, C dot append, and what do we append here is a yellow color. And still if some node is left, obviously many nodes are left having the BMI in between these two, then we do C dot append blue. Let's save it, and next let's look at the output. So you see here the graph looks, I think, all the more beautiful now. So we have these nodes. So blue nodes are mostly the normal nodes, red nodes are the foci nodes. So here you see all the nodes having BMI of 40 comes in the yellow color, and all the nodes having this BMI of 15 comes in the green color. Next we go ahead and implement homophily in this network. So let's see how do we implement homophily. So after adding foci edges, what we want to do is, we want to implement homophily. So what does homophily do? So what we'll be implementing here will be one iteration of homophily. What does homophily say is, nodes which are alike, similar to each other, they tend to become friends with each other, and we have already looked at the formula for this. So we define homophily here, define homophily G, and what does it do? First of all, it gets all the person nodes. So person node equals to get persons nodes, because you see homophily is only going to happen between the people, not the social foci. So this function is explicitly defined for the person nodes. So we get all the person nodes, and for simplicity, let's simply name this array as P nodes. P nodes refer to person nodes. So P nodes equals to get persons nodes. You can also notice here that I am nowhere past the parameter G here, because G here is being considered as a global parameter. Okay, P nodes equals to get persons nodes. So I have all the person nodes. Now I want to see whether their BMI is similar to each other, and if it is similar to each other, I'll add edges between them. What I do for U in P node, so U is my first node, for U in P nodes, and then I have for V in P nodes. So it picks each of the person nodes, every possible combination of two person nodes one by one, and obviously my U should not be equal to V, because the person is not going to make tie with himself. So if U is not equals to V, what do? Is we calculate this difference in their BMI. So what is the difference in their BMI? It is the absolute value of G dot node each, G dot node U name, which carries the BMI of this person, minus G dot node V name. So I have this difference here. After having this difference, what is the probability that these two nodes will connect to each other, as we have seen, is inversely proportional to this difference. Greater the difference, lesser the probability. Lesser the difference, higher the probability. So, probability of these people connecting is 1 divided by this difference plus 1000. So, we have this 1000 here to keep this probability small. And next, as discussed before, we have a random number R, random real number R, which takes its value from 0 to 1, and if this R is less than P, what do we do is G dot add edge between U and V. I think it's clear. So what we do is we calculate the difference between two nodes. Probability of these nodes connecting is inversely proportional to this difference, and with this probability these two nodes connect in every iteration. Let's see. So what we want to do is let's visualize the graph once before homophily and once after homophily. So this is our graph before homophily. This is our graph before homophily, and this is our graph after homophily. So you can see here now we have many relationships across different clusters. So these nodes previously they existed in different clusters, but you can see now our graph has become connected and more people has connected with each other. So here we have an edge between 35, 25, 25, 39, 39, 27 and so on. And these edges are in accordance with their body weights, BMIs. So we can make this probability actually a little lesser if you want less number of edges to be added at every step. So that is totally up to us. So we can increase this probability of connection, we can decrease this probability of connection, but the probability should be inversely proportional. So if you want to decrease the number of edges being added at every step, what we can do is we can make this value all the more higher and this probability gets less here. So you see here that this was our initial network and this is our new network. So you see here less number of edges have been added. Less number of edges have been added here.